All right, this is a video on limits. I'm picking up where we left off with the introduction of limits. I'd like you to do this while half the class is taking the test. If you choose not to do it during this allotted time, you are responsible for watching this video and completing the work by Monday. I will not formally reteach this lesson, but I can give you extra help if you need it. So I'm trying a new device with a little tablet and a pen, so bear with me if my handwriting is a little wacky on this video, but trying to get this done with as fast as possible. All right, so on the last time we talked about limits, I basically told you that when you hear the word limit, I want you to think of the fact that a limit is a y value. All right, so anytime you see the word limit, I want you to think y value. And I told you there was three ways. So three ways. This is going to be fun. Hold on a second. Let's try it again. Hold on. Three ways to evaluate a limit. Okay, what are those three ways? The first one we said analytically. And analytically meant that you were just going to do the algebra. And hopefully we know that this should be our very, very first step. When we do algebra, I want you to look at it. As you are just plugging in the value that x is approaching. So whatever x is approaching, usually we call it c, you're going to take that c value and plug that into the given equation. So whatever f of x is there, and we'll do some of that today. The second way I said was graphically. And graphically, that's when you're looking at the graph. And when you look at the graph, you're going to basically ask yourself, all right, from the right and from the left, does it tend towards the same y value? We're looking to see if the graph is going towards the same y value. Okay. And then the third way that we talked about was numerically. So here, our third way we refer to as numerically, and hopefully you realize that you need tables for that. That's the method where you need to look at a table and see what value they're tending towards from above the given value to below the given value. All right, we are going to concentrate today on number one, analytically doing the algebra, plugging it in to find the limit, which is the y value. So let's check this out. So on the first one, I just want to go through the basic rules of limits. Okay, number one here, this is just stating that the limit as x approaches c, where b is a constant, right? So if I had, let's say, an example of this is the limit as, let's say, x approaches 1 for 5. Well, we want to know what is this going to equal? If you try to plug in the 1 for x into the function that's right here, this is a constant function. There is no variable to plug this 1 into. So that means that I don't care what I'm plugging in, the output is just this constant. So remember, constant functions are horizontal, they have the same output. So the limit of a constant is equal to the constant. That's what step 1 is referring to. The limit, and you might want to write that down. The limit of a constant function. So let's change that to of a constant function. That's function, is the constant. Right, that's what that rule is saying, and that's a big one. So b is a constant, so the answer is just b. For number 2, if we look at that one, this is just saying the limit as x approaches c for the function c. You're going to plug in that c into that function. So literally you're replacing x with c, so that's why your limit is just c. This is your just typical plug in. Plug in. Okay. And then 3 is also a plug in. You're taking that c and plugging it in to the base because that's the x, and so your answer is c to the n. And this is just another plug in. So 2 to 4, these choices just plain old plug in wherever you see the variable. In this case, it's x. So for example, just so you really understand notation, if I set the limit as h approaches, let's say 2, and I give you hx, well, my answer, you're plugging in the 2 for h, so your answer would be 2x. Okay? All right, so now we want to do a couple of these. I'm going to just do 1 or 2 with you, and this slide will have the answers to follow. Let's try A together, all right? And we're going to also do, let's do E and F together, and you can do the other ones on your own. So here, if I say the limit as x approaches 4 for x squared, well, there's the x. You're literally just plugging in that 4 for where you see that x variable, and you get, okay, 4 squared, well, that's equal to 16. So 16 is my answer. All right, for E, we're just plugging in pi anywhere we see x. Well, I see x in 2 spots, here and here. So my answer is just going to be pi cosine pi. And guys, I'm stopping there, but there's actually more that I can do to evaluate. And what do I mean by that? Is that you should hopefully remember what a cosine curve looks like from last year for Algebra 2. You should have had cosine curve to be like this. And if you don't remember this, we will learn it in detail this year. So the cosine of pi is equivalent to -1. So this would be pi stays as pi, and cosine of pi turns into -1. So the whole answer is -pi. Right now, if you didn't know that final answer, if you got only up to, if you understood this part where you just sub in, I'm okay with that, because we are eventually going to do a lot of work with trig, and then by the end of the year, you'll definitely need to know that that's equal to -pi. Okay, now let's look at F. F is just a plug-in, right? So F is saying take the 3 and plug it in where you see x. So you're just rewriting, instead of the x, you're going to put 3 there, plus 4 squared. So then 3 plus 4 is 7 squared. So my final answer is 49. All right, this is what we consider direct substitution. I'm just plugging in the x value into this, into whatever the limit, I'm taking the limit of, and it's just a direct substitution to get the y value. All right, I'm asking that you do B, C, D on your own, and then you can check your answers with this page, okay? So as you see, we did A, which was 16, E, which was pi cosine pi, and then I explained why that ended up being -pi. and then F was 49. So check your answers after you try it. So now we're moving on to techniques, which is the major piece of this lesson. And we're going to have 2 videos, just so you're aware. The techniques for evaluating limits. Well, we just said the basic technique is, listen, we're doing direct substitution. So if I'm doing direct substitution, anywhere I see the x, this happens, the variable's x, and I'm seeing as x approaches -3. So anywhere I see x, I'm going to replace it with that value that it's approaching. So I'm going to do this. I'm literally just rewriting the original without the x. And I'm just going to plug in -3. So we're going to do -3 here, -3 here, -3 here. When I do that on the bottom, I get 0. -3 plus 3 is 0. On the top, -3 squared, that's 9, plus -3 is a positive 6, minus 6, well, that turns into 0. So this is a very, very, very important outcome. This has a special word. Some people will say, well, Ms. Wickard, the answer is just 0 because 0 divided by anything is 0. Well, that's true. We know that 0 divided by 4 is 0. 0 divided by 100 is 0. Okay, but somebody else might say, Ms. Wickard, that's not 0. It's going to be undefined. It's going to be an error, and I could say, oh, I see where that student's thinking that. Why is the student thinking that it might be undefined and not 0? Well, because we know that anything that has a number divided by a 0, no matter what, if you have 0 in the denominator, we know it's undefined. So I might say, okay, I understand that person's rationale. So now I'm debating, is it 0 or is it undefined? And then I have another student that says, Ms. Wickard, it's neither of those. The answer must be 1. Well, why are they getting 1? Well, we know a number divided by itself is equal to 1. So now we're really not sure. We say, is it 0? Is it undefined? Or is it 1? This is what we call, this expression here, we refer to as the indeterminate. Okay, you're going to hear that word a lot. I cannot determine right now, I cannot determine right now what that value is. When you have 0 over 0, this screams for you to do more. You must, this is interesting. I'm trying to write with this pad. I'm not loving it. You must do more, okay? So what is do more? We're going to have techniques, different techniques of how to do more. All right, the first technique of what to do more algebraically is to do what we say factor. So I'm going to pause and I'm going to restart a video so that you can see what we have to do.